Welcome everyone to the Ontology Summit 2024 Fall Series. Today is the 1st of November, 2023, and this session will be hosted by Mike Bennett, who will be introducing our two speakers. Mike?
Thank you, Ken. Hi, everyone, and welcome. So, hope you've been enjoying this series so far. We've been tracking through a whole range of ways in which ontology and large language models can relate to each other or not relate to each other, or what this one does and what that one does. And Andrea's pulled in a huge amount of work in finding us various speakers and things from that. So this week we're going to continue that theme. We've got a couple of speakers, one of whom I believe is Andrea herself. And so we're going to hear from herself. And both Andrea and we also have Prasad Yalamanchi of Lead Semantics. What they've both done in what I think are possibly diametrically different ways, I'm not sure yet, is come up with products and services that take what LLMs do and take what ontology can do and bring them together in different and very interesting ways. And I'm not even going to try and introduce beyond that into any kind of coherent description of what either of them does, but keep an eye out for how these things interact and how they pull that all together. So Prasad Yalamanchi of Lead Semantics will be speaking first. He's been working in AI for a long time, pulling together the whole well-known sort of chain of natural language processing and other AI type of things into very coherent products for AI. And so an LLM came along. We'll be interested to see what he's done with that. Andrea, I've known for a long time in the ontology world. She's been part of the IOA and Ontology Summit and all of these things, and quite a leading a thought leader on that. So without further ado, let's I believe Prasad, you're up first. Not if I understood that right. I think that was the order we're doing things in.
We didn't decide, so it's a good order. Go ahead.
Okay, fantastic. I think that's the order I had in my head anyway. So then without further ado, I'm going to introduce Prasad Yalamanchi of Lead Semantics, who will be telling us all about their latest products and how they've made use of LLMs. So Prasad, over to you. You're muted at the moment.
Yep. Thank you, Mike. Thank you, Andrea. I have one question to ask before I get going. Andrea, do I use the PowerPoint that on my desktop? Can I?
Yeah. Oh, yes, you do. Just share your screen. It's all you.
Okay, great. Thank you so much. Yeah. I will share my screen. So you should all be seeing my starter page on my PowerPoint.
Yes, we are. Full
yes,
screen.
we do.
Perfect.
Thank you. Yeah, so as the title goes, it's harvesting knowledge from language is the main theme. I think it fits in very well with how we use semantic technology and LLMs together. And both of them have come together in a product called Text Distill, which I hope to spend some time in actually demonstrating the tool. Yeah. The theme, for the product and what our company has been focusing on is really using semantic technology and large language models together to be able to extract knowledge. And in that extraction, the knowledge would have to be computable in the sense that RDF triples is our end goal. And these triples would conform to an ontology. As such, whatever gets into the triple store is well connected, and it's already in line with the ontology that we had configured the text distill pipeline to be. So our the essence of our theme for our product is that the so-called embeddings and semantic similarities, they get you not all the way in terms of accuracy of the search results, for example, across all the text corpus that you might be working through. Whereas if you were to produce a knowledge graph and use the knowledge graph to do the search, then you would get the ultimate, the accuracies in your search. And clearly, in creating the knowledge graph itself, we use LLMs and several models along the way, which I hope to be able to present. By the way, please feel free to stop and ask me questions along the way.
It would be nice if you spend a little time on the first slide.
This one here or the one before?
Yeah, this one.
Yeah, okay. So
can I just say something? Can we make sure we stick to our half-hour time limits too? So maybe you want to leave questions till the end?
Yeah, let's do questions at the end and the bottom of the hour, and then again near the top of the hour. So yeah, so we've got till 12:30.
Okay. Right. So this picture here is, basically talking about, the bottom being regular search keywords based searches, for example, across text, whereas next higher up would be using large language models by themselves, including the so-called, retrieval augmented generation that would put it somewhere on the top of this, cyan layer. Whereas if you club that with the knowledge graphs, then you have a chance to go all the way. The idea being that pursuing knowledge gives you full essential context for your searches, as opposed to even with embeddings and RAG tools. It will increase accuracies, but not all the way what you can expect with knowledge. That is the idea here, and hence our pursuit of our tool creation with this in mind. So this slide is talking about the general schematic, the high-level illustration of what the architecture is for Text Distill, our product. So on the input side, you just feed in documents of all kinds, short documents like tweets and product reviews and things like that. They could be from web and your internal corpus, and to articles, to even books even. Just feed them in on one side of the pipeline. And then out you get is a fully structured knowledge graph. And that you can expect only with an ontology in hand, unless it's an open domain, right? And so the ontology clearly would be driven by a domain and things like that. Of course, along the way, we use LLM to kind of sort out things along the way in the triple creation process. The outputs are RDF triples in NQuads, or JSON LD, and other formats are possible as well. Given that the output is a fully formed knowledge graph or RDF graph, it enables immediately the full search that you can literally a natural language search, which I intend to do the demonstration here. And the search itself is something like this. Like you have a text pane where you can put in your natural language text search string, and then it gets deployed over the knowledge graph, and then of course it has links back into the actual corpus itself. And then one of the results, if you break it down, it will actually show you the constituent documents that are actually producing the answer for you, which would be one of the results for the question you asked, right? And you could actually be able to check to see if this indeed is the answer by verifying this by double clicking, and I hope to be able to show you that. And it'll take you to however many documents, and depending on the number of propositions in the questions that you ask, it is possible as many documents may be necessary, or one less at most. So in this case here, what you're seeing, there are two documents that are producing the answer for the question you asked. And the answer itself is coming from two independent snippets, or multiple snippets from, it need not be one even, it could be multiple snippets within a document, and clearly several snippets from across the documents that are making up the final answer. In that sense, instantly you are able to verify that this answer is the correct one that you're looking for, and it fits the question you're looking at. And so in that sense, it is verifiable. So it is completely mediated through the knowledge graph. And we get there, this is behind the screens a little bit. The inputs are text documents and outputs are enquads, as I mentioned in an earlier slide. And there are, as you have seen in the schematic, there were several models working in the pipeline. They're all trained on the domain variables and the labeled data of the particular domain, based on the taxonomy. And in the case of the demo, we are trying to show, we are using an ESG corpus, environmental social governance. And this corpus is from news articles from Dow Jones. And the vocabularies, this is just an example of the vocabulary. This we have about close to 4,500 or so some terms for the climate variables and so on. Here you can see like waste plastics and battery storage and power consumption and things like that. Just a sample of what the terms are and synonym lists are. And the key thing is that we use an ontology, and then that ontology is configured in the pipeline. And when we do this ontology, clearly ontology has many more aspects to it, which may not participate directly in the extraction itself, like the super classes or the upper ontology terms and so on. So what you would need is the surface, all the leaves are leaves of interest. And, sometimes it may not be leaves of the ontology. It could be inner, within a hierarchy, within a taxonomy, some higher level classes as well. And so we have a little tool within the pipeline that extracts what our extraction graph ought to be. This is the sample portion of the extraction graph. It's like just for illustration here. You'll see that green variables are there. There are investment, organization 1, 2, things like that, what you would expect. That you might find in the mentions of the running narrative text. So that's one piece that we add to the mix in the whole thing. And net of it is that in this particular case, the ESG corpus produces a knowledge graph on which we are able to search. And as I mentioned, the particular corpus is the global news from Factiva. And then you are able to search through all that. So Factiva is this aggregated news service from Dow Jones, has some 30,000 some odd publications. And we are working with them. And this is just an FYI. We are in North Carolina, headquartered. And but the idea is I quickly go to the demo. Am I ready to go to the demo? Can I?
Yes, please do. Yeah, go ahead.
Yeah. So I'll just click on this, and it'll put me on the this screen here. This is where our text distill server is hosted, and I can log in through Google here, and I will use this login ID. So when I log in, it directly puts me into the search screen. And of course, there is a corpus that is working behind the screens, and I will show what the corpus is. I'll go to the corpus. In this case, there are multiple corpuses are loaded into the demo server here. We have ESG and a couple of others. One is archives. I think legal archives, I believe. But ESG is where we are focused on. There are about 158 documents that were processed. I'll click on the ESG, and it'll take me to looking at what is in the corpus. These are all processed documents through text distill. So as you will see, each of this section is one document. There is a title portion and little description. You can just click on this to see what that input document is. As I was saying, this is a news article. And so this is one such running news article from either Wall Street Journal or one of those Dow Jones sources. And similarly, the same thing, so you can just click around. Each of these documents are just news articles running text that we individually humans haven't seen. We just put it through text distill. And the idea is once it is processed, it has extracted a knowledge based on the ontology that was configured. And so we can just see what such an ontology would look like, or the graph resulting graph. I've just picked up 3 files, and we can click on this, and it'll pull up the knowledge graph corresponding to the 3 files that we have shown in the triple store behind. So this is literally as you would expect. It's a connected graph. This is the result of a query to the triple store. I can bring up the node labels, and I can bring up the edge labels, and you can bring up the toggle arrows here. And so the idea is, there are plenty of operations here that you can work on this graph. If you're interested, if we are able to deal with the complexity of these graphs, you can pull up one graph at a time even. But the idea is, the benefit of a knowledge graph is that you can pull multiple graphs and see if there are any common connections, as you would all know. The other thing interesting is, so I can click on these things and it will take me to the underlying text that has actually produced the nodes and edges that are, connected to the so-called the anchor node here. So in here we are seeing there is a global energy, or so global energy and Shell as a company, and so you can check to see that this particular snippet of text has Shell and global energy in here. And so you can literally click around and check to see what portion of the graph is being produced by what part of the running text. And it narrows it down to the closest text block, multiple sentences or a single sentence, depending on what the nodes that you're looking at. But I want to focus on the search. This is most of the time our engineers spend time here. They are trying to, because each of these things are a result of a prediction. Literally, it is Shell because a named entity recognition has recognized this as in an organization, and it's a cell, and hence the icon and so on. And similarly, the edges also, something is tracked here as a green variable, and that's because this was predicted as a green variable. And if I can only separate it out, so somewhere in here is biofuels, and that was predicted as biofuels as a green variable or a climate variable, and hence so all these things are predictions. And so as you would know, all these predictions are based on some classifiers and things like that. The engineers, when they are going through, they look at, and if the configurations and the classifiers don't meet what they're checking out here, they can go correct it, and it is changing in the configuration files. And so it really helps a fantastic way to debug a complex pipeline like this. So I will go to, so this is the knowledge. So these 150 some odd files, they've all been processed, and so they all reside in the triple store in terms of the knowledge that was extracted. And so on the text, now you can see the running text is now available as a full to see what part of that text has contributed to what part of the knowledge. So in this case 3 documents, and there were 124 blogs, and things like that. So there is plenty more that you can explore actually. And with a configuration, you have other menu items that will allow you to deal with the graph itself. So I will go to the search side of it. Now these 150 documents are available for search. So this is the search. I'm actually rushing through, thinking that I do not want to cut into Andrea's time. So is the pace okay? Are you all following?
Yeah. Thank you. Yeah, it's perfect.
Yeah. So now I'm coming into the open search. So I can pick the corpus. Again, it is ESG, and this is an open search across these 158 some documents, right? So I can say show companies, or let's say, I think it's a company with its location. So it's a free form search, and we make some live calls to open APIs and things like that. So occasionally the servers are not all that dependent in terms of how quickly they respond. Hopefully it'll show up. I know there is some information related to companies and locations. is able to negotiate with the LLM. Otherwise, it would have put up an error message or something. So it's still going on. The other way is, so this typing will, we can type and see, what comes back. We'll let I'm assuming, I've seen it kind of take this long before it produces some answers.
So this is the bit where you're interacting with the LLM then?
Yes, absolutely. So we are actually going to OpenAI. Together with the ontology, the prompt, everything is getting created on the fly, and then the context is sent and all that stuff.
So Prasad, I'm glad you went first because one of my comments is totally about OpenAI.
Oh yeah, okay.
I'm using it too. So I'm
yeah,
glad I went second because you're setting my stage.
Right. And occasionally, I mean, it does respond very quickly. I mean, I hope to be able to show one other query at least, given the time. And sometimes, I mean, it can just come back.
So you have 5 minutes.
Okay.
Can you describe in more detail what it is doing now?
So right now it is taking, based on the query that we had fed in, it has parsed it out. It knows that there is, a company and a location. It has, translated into appropriate terminology based on our ontology, and then trying to, formulate the prompt, and then and first goes to the triple store to get all the triples that are part of the answer, and then from among the triples it is trying to make up a summary answer for each of those things that it thinks is correct. It is possible this thing is taking a little longer than I would have thought. Let's see. I think I can just hope I am not going to use up all my time for this. I'm tempted to refresh here. I would hate to blame it all on OpenAI, but it does take some time. It is possible our own code is probably a little bit flaky here. So I will refresh, yeah. And then I will go back here and do this. Sometimes it may have cached it. Okay, so it hasn't found any answer here. The other thing is that, I can go to signals. So when a particular query works, right, we can promote it as a signal, and I can go to some of the signals that were promoted previously. And that, like, for example, I can do this. This was a similar query that was previously written down. We knew it was working. And when we promote it as a signal, so that is something that was there. And so these are the answers that would come back. And you can check to see if that answer is correct, and you can click on it to verify that, that answer indeed is like Mr. Omishakin is employed by so and so, and it comes back into this. And there is 2 ways to verify this, either through text view or through the graph view. Again, this time instead of faced with the big graph, you're only faced with just the subgraph that answers the question, So I'll try to bring up a little bit more involved thing. Like, for example, this one is another query that was tried out. And then I can click. And this is like, if you can read the description here, which company has a business arrangement and all that. And so it comes up with, all the answers. And this time it is coming with multiple um, documents producing the answer. And within each document, for example, this is AXA Investment Managers has an arrangement with Chevron, and it is reducing the overall methane emission intensity and so on. So you can click on the segments here, and they will show underlying text that would have contributed to some pieces of what you're looking here. And maybe this one here, looking at AXA Investment Managers, is here, and Chevron is here. So was led by, so there is a business arrangement within these two. And then overall methane, whatever. So that could be coming from the second document. Carbon intensity, emission intensity. So I can look at here. Lower carbon energy, or maybe this one here. Overall methane emission intensity, as you can see, so this particular answer is indeed coming from, the segments here. And same thing you can verify through the graph. Again, this is just bringing the subgraph that would, give you a chance to go to the same underlying text blocks that will, give you the comfort that this indeed is the correct answer. So these are all the, so the other way is you can go in here and say, okay, I know, let's say, so this is
Prasad, we're hitting the bottom of the hour now, so
okay.
Summarize.
I did notice that we started at 12:06 or something. But I'm okay.
There's a bit of flexibility there. I apologize.
Sorry about that. Because so this is, if you will notice, so you are able to kind of, this was a template that got created by the question that we asked when we promoted it as a signal. And then now you can fill in. This time Barclays is having a business arrangement with all these open variables. And so you have all these things. You can go back in here and maybe, I know carbon is used all over the place. Let's say carbon capture and Barclays, if there is two together, will bring in anything specific to just that? So these are query results going to OpenAI even, so the same thing. So this time it's only 2, and you can double click every one of these answers. Again, you can click around and just verify that they are indeed being supported by the underlying text, the specific text, both either a graphical way or in the text way. I will stop here for any questions.
Well, can we keep questions to like near the top of the hour? So
sure, absolutely.
And there's some questions in the chat as well, so you can get a head start on those.
If I have 2 more minutes, then I think I will show just that open search. I think OpenAI sometimes kind of gives a big break. Right now these are produced coming back properly.
Okay, let's see what happens.
So I'll say I'll just do this. What was the issue with this? Show company and say and its location. Right. So you can click on this and see, it's coming from Alliant Energy is based in Edgewater, and you can go here. Alliant said it is continue running its Edgewater plant. So that's how. So I'm glad at least it went to the.
Excellent.
So as soon as it detects that it is a proper string that it can understand and all that, it creates a template as well. So you can actually promote it as a signal. And this is the process how you can promote it as a signal, give it a name and all that. So that you don't have to type in, much like how I was making mistake. You could probably directly go to signals and select what you were interested in. So that is the idea. I will stop here.
Thank you very much, Prasad. It's exciting. So we're seeing how you're using the LLM there as part of the querying process on top of a mature stack of NLP stuff. So now we'll see what Andrea Westerinen has that could be similar, it could be very different. Very excited to see what you've got for us. So Andrea, over to you.
Okay, Prasad, I don't know, can I? Oh, I'll just stop yours and I'll go to my desktop and I'll get rid of that and I'll go to, let's see, I will go to screen share. Actually, it was great that Prasad went first because some of the things I'm going to talk about are the learnings I've got, because everybody knows the title, Populating Knowledge Graphs. World has changed with the use of large language models. I'm going to go to screen share. Why is it not screen sharing? Oh, that's not what I want it to do. There we go.
That's the one.
And much better. And this one use case. So I have this app that is really a research project. It's really a research prototype. And its main goal is right here. What I would love to do is help people who are willing to learn to better understand how the news that they get is tuned to them. So how the New York Times tunes more to liberals, to the left, and how Breitbart is tuned more to conservatives, to the right. But what's actually going on inside that text underneath? And then can we use this to help discover patterns and things that could lead us to better understand mis and disinformation and how everything is being built to engage and enrage us. So DNA originally started doing everything with NLP and moved in the last couple months only to using LLMs. And this presentation is about that and about the learnings that I have. And it's all open source. It's up on GitHub. Full disclosure, open kimono, and it's not perfect. It's a prototype. We're creating knowledge stores with data from text. And the whole goal is to put the information, very similar to what Text Distill is doing, put the information from a text in a named graph in a graph database so that it is stored, it is maintained forever. You don't have to keep reevaluating it. You can do all kinds of drill downs, both within an article, across articles, across publishers, all kinds of things, as well as how does it look when you start to include other information and background sources like Wikipedia, Wikidata, geonames, and those sort of things. So that's what DNA is. It's not a product. You said product before, Mike. It's not a product. It's really a research. No, don't worry. It's a research prototype, right? My architecture picture looks very similar to Prasad's. Makes me feel good, thinking I got it right. We have a definitional ontology going that's fed into a knowledge graph, but we also take this narrative text and articles and background information, bring it all in, organize it with the LLM, stick it in the knowledge graph. Whoops. The part I'm talking about is the thing in green. Okay. Foundational technologies. I'm not going to spend a lot of time because I can answer more questions later or go into this differently. The whole ontology is based on linguistic event theory. And that's all built into the DNA ontology, which I'll show in a couple slides because I have some pictures. But because it's based on linguistic event theory, it aligns really well with linguistic and syntactic pattern analysis that LLMs do. So it kind of was a really good fit. And I still use spaCy. And so I have these two very different natural language processing aspects. And I'm probably going to be moving to help spaCy validate LLMs and LLMs validate spaCy, because software always has bugs. in the future. But right now, spaCy is doing its named entity recognition and extracting quotes and creating, the parsing of text into sentences. And then those quotes and those sentences are analyzed using OpenAI to get their linguistic details. But I've also, because remember, my goal is to help readers understand engagement and enragement, what rhetorical devices are being used. And LLMs also understand semantic role labeling. So can we help use that to pull out more information about the events that are discussed in an article, the timeline of events that are discussed, so that you can see the author talked about A, then he talked about B, then he talked about C, another author talked about A and then went to D, kind of missed out on things or decided to ignore them, because omitting something is not the same as lying. It's just I'm choosing the facts I want to use, which people do all the time. DNA is also using other things like ontological reasoning and inference to build new information. It's trying to do this graph analysis and pattern recognition. That's not the subject of today's conversation. I'm not going to spend a lot of time on that. DNA, because it's a prototype, is just a bunch of REST APIs. So you can create repositories in a database. You can retrieve news. And when I'm saying retrieve news, I use the news.org.api. I use the free version. But so you can retrieve articles and then pick the ones you want to ingest, or you can retrieve articles and automatically ingest them, a specified number of them. You can take text that you have internally, pull out the parts you want, feed it into this narratives API to have it ingested. You can retrieve graphs so that you can do further analysis on them, like in Network X and, all the do why and all the tools that exist right now. And also this is intended for the future to be able to allow people human intervention to update, because I'm building little mechanisms into the results to say, the LLM failed here. So there's none of this kind of predicate information in the database, in the graph. Therefore, you might want to add that as a person. Or the call to Wikidata couldn't be disambiguated, so there's a disambiguation text that you can find, and humans can do more things, update a graph and put it back into the knowledge graph if you want to. There is no special fine-tuning that was done, no training, no background taxonomies, because I was just trying to see what the raw use of just linguistic and semantics can do. So clearly, if you put background information and other things, it would get better. Core concepts in the ontology, and this is just an ontology picture. They're all up on GitHub. Who, what, where, when, how. You can think of that as the, linguistic event theory from Davidson. But also all kinds of metadata about the information source, like the narrative. How long was it? Maybe you only want short articles, or maybe you want long articles. What kind of interpretation would the LLM say if you were looking at it from right, left, or neutral? Or we actually have some other, in DNA, some other segmentations that are proving very promising, but in the current stuff that's loaded in GitHub, it's just right, left, and neutral. What does the LLM think the goal is? What rhetorical devices are used overall in the narrative? But then you can also do this at the sentence level and ask for sentiment analysis. And the LLM has been doing pretty good. I've just asked it positive, negative, neutral for sentiment analysis, much better than some of the current tools, or the tools that I had been using a couple months ago. For example, Liz Cheney's loss in the Wyoming primary, in one of the texts said, was a remarkable fall for a great political family. Well, sentiment analysis, because I found the word remarkable, said, oh, positive, but the LLM said, of course, that was negative. So there's all kinds of information that you can have about the sentence. Sentences are in named graphs encode sources, and a narrative is a kind of source. And so you have, that's the basic ontology. Because I want to talk about lessons learned, and I'm just going to quickly check my time, I'm good. Early versions are based on spaCy, WordNet, VerbNet, FrameNet. I have tried them all. And they're good. They're good at what they do, but there's a lot missing. And that's the real problem. We supported a very basic parse, ontology alignment, the knowledge graph creation. Those pieces have been maintained and moved forward. But like I said, sentiment analysis was difficult. I also was very worried about multilingual word nets. And so I put a lot of work into language tags in the RDF and investigating multilingual word nets and using word net synsets and doing all kinds of that. But the problem is the complexity of human language. End of story. And the customizing of this information, or the adding to WordNet or FrameNet, because clearly it doesn't cover everything, just was prohibitive. It didn't scale in any way. So where do we move to now? And what was the proof of concept that I was doing, the prototype? What was it looking to determine? It was looking to determine the value that LLMs might bring. And so what I actually found was that obtaining the linguistic details plus sentiment was much better using LLMs and a very simple code base. Now, the LLM code base is not simple or easy to create or anything else, but the code base was. I added this concept of identifying rhetorical devices in text, which, in my opinion, would be very difficult to code up. And I've never seen examples of that, but I haven't, of like toolkits to do that, infrastructures in Python to do that. But I can't say I've looked extensively. Semantic role labeling was actually pretty good using the LLMs. So using that to do the entity relationships, again, using the summarization, interpretation tools of the LLM, it worked pretty well. And the mapping to the ontology is kind of rule-based. It's rule-based based on, I use an LLM, have it return JSON, and it's based on taking that JSON output and mapping it to the ontology. And so that became much easier. And as an example, this is the code. This is what the code used to look like. I had things going all over the place, looking at NLP, trying to generate the ontology mapping. And now it looks like this. That's what the code base looks like. Those are the Python modules that are in it. By the way, DNA is written in Python. Prompting. Now prompting is a huge thing. All the prompts that I'm currently using are in this file, query openai.py, that's in the DNA directory. And I'm going to show an example of it, go from context to instructions. I give multiple choices to the LLM, and really those are the techniques I used. Instead of doing chaining to OpenAI, I chain in my code. So it's a series of prompts, and you can see them all in this query OpenAI, that are chained in the narrative analysis to do rhetorical devices and viewpoints at the sentence level to get my linguistic details and the event ontology mapping. And then outputting always JSON results. So here's one of the examples of analyzing a quotation from a news article. You're a linguist, so I'm giving you context. Here's the text of a quotation. Now, what I found was sometimes ChatGPT got confused on where the quotation ended. If you put quotation marks around the quotation that already includes quotation marks, it gets messy. So I just said, hey, there's these 2 stars here. Ignore them, but that's where it is. So it's very clear. a very specific instruction, give me its sentiment, give me a summary, give me the grade level, which is interesting. It's just interesting what the LLM thinks, what OpenAI thinks. And then return the response as a JSON object with keys and values defined by, and then it inserts that format. Sentiment, grade level, summary. So really nice. There you go. And so I wanted to go through an example. I didn't want to do it live because I feared OpenAI would screw me over and take too long. Usually to process a full sentence in a narrative and a sentence of, like thousands, it could take 10 minutes, but this is a prototype proof of concept, so I'm not feeling too bad about it. Nothing is tuned. I made something up. John's a musician. When Mary goes to the grocery store, he practices guitar. I gave it some title, publisher. All of this stuff would typically be obtained through my news API from news.org. And I just said, stick that text as the narrative text. And what came out of this analysis, going from spaCy breaking it down to the LLM analyzing it via these prompts, is that you had this graph database, this named graph that encodes this narrative, and they're given arbitrary UUID names. So you have a narrative and an information graph, and the graph has 47 triples in it that came out of encoding that John's a musician and when Mary goes to the story practices. And it was created yesterday because I keep evolving this. So I tried to get the most recent. And the narrative came from the Wall Street Journal. It had this text. It has a goal of describing what's happening currently and a life story. It's a pretty good guess at what the narrative goal is. It has a summary, pretty good. It links to wherever that article was supposed to be posted, and I made this up. It's got 79 characters in it, and it had a very bad title. But now if you go down to the sentence level, and this is actually the RDF that's generated out of the tool, that are stored in the information graph. Every narrative is in its own graph. You can see that it knows that the sentence talks about Mary and John. So if you were looking for how many articles talk about Trump, you could find that. Mary's a person who's a female based on the name. It's guessing this because it doesn't know for sure. It's in the active voice present tense. It's the grade level 2. So somebody in second grade could understand this sentence. It talks about movement because Mary's going to the location store. And it talks about an art and entertainment event because John is playing a guitar. So that's what came out of this basic parsing, which isn't too bad. And here's an example of rhetorical devices. So at this sentence level of Cheney conceded defeat, it's saying what kind of rhetorical devices are being discussed in the sentence, not at the narrative level, just in this one sentence. Ethos and kairos and pathos are discussed. So those are appeals to emotion, appeals to specific dates and time. You could argue this one because the Republican primary is really not a kairos. It's not like Christmas, something like that. This got to be defined a little bit, but it does definitely use pathos in the kind of wording it's using, the emotional wording that's there. Oh, wait, ethos is appeal to authority figures. I had it backwards. Sorry. Ethos is authority figures, kairos is specific event, and pathos is emotions. So not too bad a job. Findings, making sure, I'm good. The proof of concept was very successful. With far less code, I got equal or better results. That were more extensible, I thought, but it's really important to understand exception handling and programmatically validate results. Because if the LLM doesn't understand something or gets confused, when you say, don't give me anything but JSON, it totally gives you just a string back that sometimes says the JSON would be : and then it sticks the JSON in. It's so annoying. So accounting for that, or sometimes if the sentence is short, the LLM decides that, like, Joe is conservative, has no verb. Well, I don't think that's quite right. So some of the stuff I've been working on recently is, can I better tune these prompts? Can I improve the validation and checking stuff? And sometimes can I retry, because sometimes OpenAI just disappears into the ether and never comes back. Using consistent terminology is really important too. Don't change the words used to refer to things. And keep consistent bunches of, I want this, and then I want this, and I want this, keep that together. I know that accuracy would be improved by using a self-consistency prompting technique, that something's repeated, which will take more time. Prompts certainly affect performance time. We saw that. But at least for me, OpenAI has, over the last week or so, been handling every prompt. It never really timed out. It never timed out at all. Not never really, it never timed out. And these are all the areas I want to keep working. My tests all are continuously evolving as my prompts and everything are evolving. My validation is co-reference for a, who is this quote attributed to? Because you might have quote, 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 you know, couple of them with different speakers. That works pretty well, but not just quoting of this really long text across sentences. The LLM gets confused. More use of background information. Like I said, right now it's Wikidata, Wikipedia, and GeoNames. I want to do a local LLM implementation to get away from just using that public API. Deeper ontology drill down. Right now, it only maps across the top level. I have the top level ontology converted in the prompt into a numbered, pick one of these things or a couple of these things that this entity could be. And then, do I have the right level of analysis? Right now, I'm doing the full article in sentences. Maybe it's a chunk of the sentence, maybe it's the paragraph level. I'm kind of investigating what's the right way to get the optimum amount of knowledge out. And that's the end of my talk. And I think I did okay. Okay.
Fantastic. Thanks, Andrea. And interesting to see some of your prompt engineering there, and things like always having to use the same words, so our semantics doesn't extend as far as talking to LLM itself. And loved your little hack with the quotations and stuff. So we have 5 minutes for questions from either speaker. There's a bunch of questions in the chat. Never know quite where to start with something as long as the chat. So and I'm going to have to hop off at the top of the hour anyway. I know we sometimes take this a little longer for those who want to stay, but would anybody like to raise a hand if they have a question for either of their speakers? Ravi Sharma has raised his hand.
Always, but I would let others go if they have more questions. One question for Prasad and one for Andrea. The question for Prasad is, you showed some method of creating things under the hood by processing and using ontology, which was great. But if you repeated that process without doing anything else, do you get the same result back, or does it depend on how it aggregates entities and relationships for the knowledge graph? Would you get the same triples? Just say something about that.
Yes. So for the same text document, for example, I'll take it from in the pipeline standpoint, the same text document for the same configuration, without changing any of the prompting and in all of that, will produce the same minor modifications. Even those will not probably cause anything at all in the number of tests that we have done on the creation of the knowledge graph side. On the query side,
Sorry, go ahead.
Yeah. On the query side, again, the query string, as long as the query string is the same, because we are, again, mapping it to the ontology elements before we go to the triple store, and then bring back the triples that qualify the query. and then go to the LLM to create the summary answers. So the summary creation is likely to be a little bit, again, the language there, but the actual elements, the ontology elements, which are like the entities and all of those will not be different at all for the same input.
You mentioned somewhere you used engineers or expert to edit some concepts or validate some concept. Where does that process repeat?
That part is, the entire flow is completely automated. It's only at the time of creating the ontology. That is outside
Okay.
of the pipeline anyway.
Thank you.
Next question.
Another one for Andrea, if there is no one else, is Andrea, this OpenAI, can you explain where does it use the AI part? Where does it use the machine learning? And what is under the rug that you know of? Whether it's published.
So OpenAI publishes the ChatGPT interface, and I'm not using the ChatGPT human interface. I'm using the API calls. So I'm actually doing chat completion and just making a call. So if you look up openai.com, you can see, or if you look at my GitHub, it says you need an account on that to use it. But that's the LLM. It's basically OpenAI's API is ChatGPT, and I'm using GPT-4, not 3.5. There was some dialogue with Douglas Miles on the chat channel. 3.5 just was insufficient for me.
Thank you, Andrea.
Does it use ML? Does it use ML under the wrap?
Well, the OpenAI ChatGPT uses the whole LLM infrastructure and then uses that under covers. So I'm not coding it. It's OpenAI who coded it.
Thanks.
Fantastic. Thank you, Andrea. I don't see any other hands raised, and we've reached the top of the hour. Do look at the chat, and I don't know, Ken, if you're able to save the chat, because many of the questions were answered there, so it was good not to duplicate that effort. Thank you very much once again, our two speakers, Prasad Yalamanchi and Andrea Westerinen, and thank you, Andrea, for running pretty much the whole of the rest of this mini series, which continues for another couple of weeks. So I think without any further ado, do I need to hand it back to Ken to wrap things up? Otherwise, thank you for a fantastic session, great insights, great, very different combinations of stuff, and that's what we were hoping to see. Thank you. Ken.
Thank you.
Thank you. Bye.
Thanks, everyone. Yes, I am saving the chat, and it'll be posted on the meeting page.
Fantastic.
In the meantime, I hope everyone will be coming to the next session, the penultimate session, where the topic is broader thoughts. We're going to have three speakers: Anatoly Levanchuk, John Sawa, and Aaron Majumdar. So I hope everyone will be coming to our next session. And thanks again. And we'll now adjourn.
Thank you.
Ken.
Thank you.
Thank you.
Bye, everybody.
Great job.
Thanks.
This is really wonderful, Andrea. Thank you.
Thanks.
A lot of thought has gone in organizing this, and I'm very happy. It's coming out very well. The whole series, I mean.
I'm really happy with it. I'm really happy with the participation.